Good morning to one and all. I am Dr. VINKEL ARORA, Assistant Professor in Department of Food Engineering, and today I'll be discussing one of the important aspects, that is the temperature mapping and monitoring in the cold room. Temperature plays a very important role when we talk of the storage in the cold room. So let us discuss what are the various important aspects, what are the challenges, and how to address the problem in the temperature mapping in the cold room. So any perishable food facility operating at a specific temperature, for example freezers, cold stores, loading, unloading docks, they require temperature mapping exercise. This is a very important exercise ensuring the quality of the food in the cold room. So we have to locate the hot and cold spot within the area by means of the temperature distribution within the zones. So this particular exercise is temperature mapping exercise. What is to be done? So temperature mapping has 4 stages. First is to prepare a mapping protocol, carry out the mapping exercise, prepare the mapping report, and implement the recommendation identified in the mapping report. So newly established cold room or transport area should be temperature mapped before the installation. So this is one of the important requirements. So the temperature mapping procedures should demonstrate the air temperature profile throughout the storage, both empty and normal rotated. Defining the zones where products should not be stored, for example area near the cooling coils, cold air streams or heat sources, because they will obstruct the flow of air and ultimately affect the temperature distribution. In the event of power failure, time taken to exceed the required temperature limit should be clearly demonstrated. So routine monitoring as well as subsequent mapping practices is required periodically every 1, 2 or 3 years. Whenever there will be modification inside the storage area, remapping should be carried out. Documented properly to demonstrate the compliance to the management, clients and the regulatory authorities. Now let us discuss how to do this particular temperature mapping through methodology. So a detailed and comprehensive protocol should be prepared, reviewed and approved before the mapping exercise. So the mapping protocol should be having the following section: approval page and the change control history, acronyms and glossary, description and rationale, scope, objective, methodology, mapping report templates, annex as needed including templates for the mapping report. So steps 1 to 5 should be completed before the final approval of the mapping protocol. Now let us discuss the steps for the electronic data logging monitor. So this will be normally called as EDLM. So this is basically the logging of data for continuous monitoring of temperature, humidity, airflow or the data which you require as per the cold room. So they select the type of EDLM which have sufficient memory throughout the study for selected recorded intervals. For example, here the data loggers with different storage limits are available in the market. So National Institute of Standard and Technology, they have a traceable 3-point calibration completed. So if it is following a standard, it should be ISO 17025 accredited lab if possible for the calibration. So error or the uncertainty in the measuring instrument should not be more than plus minus 0.5 degrees Celsius for the temperature. So a valid calibration certificate should be attached with the mapping report. So for example, here if you see in the picture, so this is a contact type and non-contact type data logger, and here at the back end, so this is the report which is generated by the electronic data logging monitors. So calibrated for the desired temperature at 3 points are below the low end of the range. For example, if you have set the range from let us say 4 to 10, so it will be calibrated below low, means below 4. Middle range means between 4 to 10, maybe 7. Above the high end of the range, for example if you are keeping 10, so it will be calibrated at a temperature of 11 to 12. So use only one device for the study, so this will ensure the consistency of the temperature monitoring. Advisable to use the EDM with monitoring of door opening, that is the simulating work entry or exit throughout the mapping. Now here it is very frequently required to open and close the door for loading and unloading or taking out the products or keeping in the products. So this should be carefully monitored in the temperature monitor. Second step is to designate mapping team. Identify the list of team members according to the task. Record their initial and signatures for the ease of tracking. Ensure their training for the specific task. Survey the site. So the survey of the site should be done before this particular mapping. So conduct a survey of the site to be mapped. Each thermally separated area being mapped will be followed with the information, for example, length, width and height of the area, container, room, store or warehouse. Drawing of each area showing different elements, for example, if you are placing pallets, racks or shelf, should be accurately as they can affect the heating and cooling of the surrounding space and can be used to place the EDLMs. Specify the location of heating and cooling components, including the air distribution outlets, lighting, ceiling fans, controls or etc. The location of equipment existing, temperature recording and the controlling sensors. I think this important exercise will clearly tell that where the EDLM should be placed and you should know the exact dimensions of the area. Now, establish the acceptance criteria. Now the protocol should define the required acceptance criteria for the food product, whether it is frozen, chilled or dry, with all the acceptable ranges within the mapping area. Some mapping studies can be performed without predefining the acceptance criteria because the temperature range is wide, so you can have some acceptance criteria or you may not. But it is very good practice to define the allowable temperature ranges. Next is to identify door opening, if any, that should be mentioned specifically in the methodology and the acceptance criteria. If there is a door opening, then the frequency and duration should be clearly mentioned. The temperature to be maintained to the desired limit up to 30 minutes of door opening. I think this is an important parameter which should be clearly mentioned. Determining the EDLM location. So survey the site and the risk-based approach can also be used. Consider the following, for example, length and width. So EDLM, that is electronic data logging monitor, should be placed in a grid pattern at every 5 to 10 meters to cover the area. The layout of the area, for example, it can be square shape, rectangular shape, it can be any L-globes. The degree up to which the shelf and the product can also affect the air. EDLM should be placed in the location near to the product are placed or planned to be in the store. Any consideration which can make efficient use of the EDLMs. Next important aspect is the height. For example, if you have the ceiling height that is 3.6 or less meters, so place at a height of 3 meters, median for 1.2 and low means at the floor levels. So if the ceiling height is more than 6 meters or more, so place at the bottom, middle or at the top of the surface. For example, for 6 meter height area, EDLMs can be placed at a height of 0.3, 1.8, 3.6, 5.4 meters. So this is the criteria for placing the electronic data logging monitors. Now for example, here if you see, there are the two important aspects which are showing the grid positioning of the EDLMs. So this is for the floor, this is for the middle and this is for the height. So these are the storage racks where the products are to be placed. So in case of higher heights, so you can have at 1.3, 1.8, 3.6 and so on. So these colored textures are showing the position of the EDLMs. Next step is to record the location of the EDLMs, monitoring sensors and thermostat. A data sheet should be provided to record the locations of the temperature sensing devices. For example, information like EDLM, sensor ID numbers, serial numbers, mounting height, set point of the thermostats. Now for example, here in this test data sheet, you have the data logger ID number, for example DL001, DL002, 3 and so on. So the serial number of the data logger should be entered. Then ID number as per the schema. So means at which height you have placed, and for example for 6 meter height it is 0.3, 2.8, 5.4, and the second you are taking on the other side 0.3, 2.8, 5.4, and then description or the any comments. Now temperature distribution, the information of the thermostat which is being located, for example one at the entrance door and near the loading door. So for example the set point is 20 degree and it is locked. Step 7. Label and program the EDL. Label each EDLM with unique ID and the manufacturer serial number. Ensure that the device can be traced for calibrated using serial numbers. Ensure same time and recording interval. For example, generally between 1 to 15 minutes for all the EDLM, depending upon the storage space within the electronic data logging monitoring system. Starting time enough to fix all the devices at all the positions. Step 8. Fix the EDLMs in position. Position exactly same as mentioned in the data sheets and drawing. Place and fasten. Prevent any damage or displacement during the storage operation. Sufficient time for EDLM for condition to the ambient before mapping. Step 9. Conduct the mapping exercise. In general, there is no time limit for the exercise. Normal warehouses run consecutively for the 7 days. Freezers or cold room between 24 to 74 hours normally. After completion of the mapping exercise, collect the EDLM data. Double check the serial numbers and the locations against the data information. Step 10. Download all the consolidated data. Download all the EDLM readings and consolidate the data for analysis and description. So now the important part is, once you have got the data, analysis of the data and preparing the mapping report, because acquiring the data is one aspect, doing the exercise is another aspect, and analyzing the data for ensuring the quality of the product by temperature dependent quality of the product is important aspect. Now let us discuss the analysis. So primary analysis include analyze the temperature stability of the mapped area, identify the temperature variation occurred, compare the measured temperature data with the acceptance criteria. If you have defined the acceptance criteria, you should be comparing that with the results. Overall temperature stability analysis considering the followings. The ability of the environment control system to maintain the temperature within the acceptance criteria. Overall temperature stability and fluctuation experience during this study. Now let us discuss the analysis. So primary analysis include analyze the temperature stability of the mapped area, identify the temperature variation occurred, compare the measured temperature data with the acceptance criteria. If you have defined the acceptance criteria, you should be comparing that with the results. Overall temperature stability analysis considering the followings. The ability of the environment control system to maintain the temperature within the acceptance criteria. Overall temperature stability and fluctuation experience during this study. The analysis of the temperature variation considering the followings. Temperature variation experienced by the individual EDLMs depending upon the size of the area, position of EDLMs, temperature variation along the horizontal and vertical planes, temperature variation between the area nearer to heating and cooling units and the area far from that. I think this is a very important aspect, and experienced person can be very useful in positioning the EDLMs. Next important is minimum and maximum temperature and the hot and cold spot. Temperature fluctuation gives us the data of the lowest and the highest temperature. Either both of these temperature can be outside the acceptance criteria limited. Mean value of these temperatures should be also recorded. Cold spot and hot spot to be read. For example, in this study with the acceptance area between 5 to 20 degrees. For now here we have set the limit. For example, 5 to 20 means the lowest temperature acceptable will be 5 and highest acceptable temperature is 20. A cold spot is the area which records the lowest temperature within the acceptable For example, if the area is recording a temperature of 4 degrees Celsius, then this particular spot will be recorded as a cold spot. Similarly, a hot spot in the area which record the highest temperature but within the acceptable criteria, that is 20 degrees Celsius. So the purpose of these hotspots is to identify the preference spot where the sensor should be placed. These spots are needed to be determined seasonally because the variation is according to the seasons. For example, winters, summers, autumn. Mean temperature. Arithmetic mean temperature, that is the average of the highest and the lowest temperature that can be achieved in a region, can be applied to individual monitor sensors. Useful for the area for higher temperature fluctuation. The mean of all the EDLMs can be compared to determine the area with the highest and lowest mean temperatures. Now, for example, here we have recorded the temperature. This is the temperature which is being recorded. So this is the fluctuation between 4 to 7. This is the fluctuation which has been recorded. This is the second temperature which has recorded, which is showing the variation from 8 to 9. So we have to take the mean temperature. So here this is the mean temperature line and this is the recorded mean temperature. Interpreting the result and making the recommendation. I think this is the most important part in the temperature mapping exercise. So record and document the temperature variation observed. Also consider that the EDLM readings errors specified by the manufacturers, that is the uncertainty of the instrument. Use the data analysis to assess the overall temperature stability with relation to the acceptance criteria. Assess the overall thermostability, including the high and low temperature experience. List out the factors affecting these variations. For example, the location of heating and cooling components, doors, windows, access, or the person entering, the commodity which is loaded, or airflow. Make the recommendation for highly sensitive and less sensitive product storage space. Make recommendation for optimal location for the placement of sensors used for routine temperature monitoring and for control samples, sensors to activate heating and cooling system. Last step is report auditing. The whole report should be audited and peer reviewed by the qualified person. Includes data sheets, results, spreadsheet and graph. The reviewer should confirm, approve and sign the report, results and recommendations. Implementing the mapping report recommendation. Now here the last step is, once the recommendations has been given, it is the main step is to implement those recommendations. The final outcome of the exercise is implementation of the report of recommendation. This includes a drawing or diagram showing where the products can be stored. This can be subdivided into different zones. Allocating the pallet bay to specify the category according to the product type. For example, here depending upon the requirement of the product, the space can be designated. Repositioning of the temperature monitoring sensor and control sensors. Now, if it is placed right, it is okay, fine. Otherwise, we have to reposition according to the recommendations. Adjustment of the air outlet to reduce the temperature fluctuation, that is minimizing the hot and cold spot. Upgrading the system to improve temperature control and efficiency. This is if required, then we have to do. Now let us see a case study, because this is the theoretical aspect which we have discussed. Now let us discuss a case study where we can see what happens in a temperature mapping exercise. So here let us say we have a cold room and there the sensors for monitoring the temperatures are placed. So these are the 10 sensors 1, 2, 3 placed at the front end, followed by 10, 11, 12 which is on the front end of the cold room. 5 and 6, 4, 5, 6 they are placed at the rear side of the cold room. Similarly 7, 8, 9 they are placed on the rear right hand side. So if the total configuration is made, so 12 sensors are placed. One is at the door for monitoring the opening and closing temperature. So this is front left hand side, front right hand side, rear left hand side, rear right hand side. So total 12 sensors are placed. Then you have the optional sensors from 13 to 20. They are placed in the high risk zones and then shelves. So if there is a high risk zone, that is the near to the evaporator outlet or to the shelves, they can be placed. Now what these profiles they are indicating, for example here if you see, this is the lower limit. For example, the lower limit is set as 2 and upper limit is set as 8. So this is the temperature profiling by the different 8 sensors, that what is the temperature range you are achieving while the temperature is being monitored. So here the plot between temperature and time is made. So here you can clearly find out that for sensor 1 and 8, the temperature achieved is within the described. Then the mean kinetic temperature for all the 20 sensors. For example, here you have defined the lower limit as 2 degrees Celsius and upper limit as 8 degrees Celsius. So now this is the mean kinetic temperature. For example, for different sensors, let us say the temperature recorded by the first sensor is close to 6. Similarly, for second sensor it is below 6, then maybe close to 5. And if you see generalized, this is well below the design limit, upper limit and the lower limit. But here if you see the temperature which are closer to the 8, means ki here the temperature given by the sensor 12 is showing a higher range. Now temperature mapping study in a cold room which is newly installed. For example, here the temperature which is measured in a newly installed cold room. So you have the acceptable limits. So lower limit is set, let us say at 2 degrees Celsius, and the upper limit is set, let us say at 8. Now if you see the fluctuation, the recorded temperature, it is well beyond the upper limit. So this fluctuation means that the temperature achieved in the cold room for sensor 3 and 11, they were higher than the upper acceptable limit. So it means this will definitely affect the quality of the products which are stored in the cold room. So here, depending upon your acceptance limit, you can clearly decide whether the product is acceptable during the storage or not. Now sensor 18, if you see here, this is the again the plot for 20 sensors which are being placed, defining the lower limit of 2, upper limit of 8. Now for example here, if it is showing the temperature of different sensors, most of the sensors are showing the temperature above the higher limit. It means that these sensors are recording the temperature which is higher than the acceptable limit. Only the sensor 18 is recording a temperature which is within the acceptable range. So here I think this is another clear-cut depiction where the temperature monitoring plays an important role to assure the quality during the storage. Now how to address these problems? So first option is that you can adjust the refrigeration controller, which can be adjusted to 2 with a differential of plus 5 degrees Celsius. So maybe the compressor stop working as the temperature of the cold room reaches 2 degrees Celsius. So you can restart again when the temperature inside the cold room reaches 7 degrees Celsius. Now here, once the problem is identified, these are the issues that we can address, and this is as per WHO 2018 guidelines. Now once the controls has been again set, now if you see the temperature limit, so it is well below the higher limit. So here if you can see, this is the temperature which is being achieved by the different sensors, and now all are green, means they are showing the mean kinetic temperature of these sensors within the limit. Now temperature mapping study in another cold room which is newly installed. So this was another study which was carried out where the temperature for different sensors, 4 sensors were installed, and then the lower limit was set to 2 and upper limit was set to 4. And then the temperature was initiated at 30 degrees Celsius and it was run from 725 to 1235, and the temperature is being recorded. So if you see in a newer installed cold room, this ensures that the temperature is always higher than the higher limit. It means that it will be not going below the 14 degrees Celsius. So it means it requires further modifications and then ensuring the temperature below the acceptable limit. Now the addressing the problem, so this may be due to the default cooling unit and refilling the refrigerant in the cold room. So this might be the reason that the compressor is not working properly because of the lower amount of the refrigerant. So the refrigeration unit working stations, this can be verified. Refrigerant leakage, that can also be checked. If refrigerant is leakage, the cooling circuit, that should be properly checked. And then the temperature mapping should again be carried out for such cases. So again, once the for example, the rectification has been done, again this same is plotted, and then the temperature limits for these 4 sensors, they are found within the acceptable limits. Now what is the conclusions? So above studies, they have shown the importance of the temperature. So number of problems which can occur, which can lead to the temperature fluctuation. Secondly, temperature mapping helps to identify the specific spot or area where the temperature fluctuation actually occurs. These spots may not be identified during the regular temperature monitoring. Temperature mapping should be the part of monitoring system before installing the new cold room or after the major repairing within the existing cold room, and it also ensures the efficient cooling. So I think this we have already discussed the important aspect of the temperature mapping. So with this, I thank you all for your patience listening. Thank you.